So hello there and welcome to another tutorial. My name is Tanmay Bakshi, and this time we're going to be going over how you can use the new Turi Create deep learning library by Apple in order to create a movie recommendation system for iOS. In fact, this is actually my very first code pattern that I've developed, and you can find out all about that in the description below. I'm going to have a link to it, and code patterns are essentially building blocks of code for you as developers to build your own applications, but they're not just building blocks, they're real applications that you can modify, you can customize, and even combine however you'd like to. But before I get into the code pattern and what the code actually is, let's begin by talking a little bit more about Turi Create and how the entire system works. Now, the use case is to create a movie recommendation system, and so I'm sure we all have experience going through a bunch of movies and trying to find new movies to watch. And occasionally it becomes frustrating because there's so many options and you get confused, you don't know what to watch. Sometimes you watch a movie that you think you wouldn't like, but you actually end up liking it. And so how do you know what you should watch before you watch it? This is where the recommender system comes in. But in order to do so, you need a lot of data, you need a lot of computing power to process that data, and you need to build the algorithms behind that processing. And this is where Turi Create comes in. You see, a little while ago, in fact just a few months ago, there used to be a deep learning library called GraphLab Create. It's an absolutely exceptional deep learning library, and Apple bought out the company. Apple then, at WWDC, had open sourced GraphLab Create as a new open source version called Turi Create. The differences between GraphLab Create and Turi Create now are really only skin deep. The back end is completely the same. You're still using the same S-frames, and the best part is that it's meant for performance, and I'll get to that in just a moment. But the best part is that it's really meant not just for machine learning developers, but for app developers. What does that mean? Well, this is not machine learning with an algorithm-focused design. It's machine learning with task-focused design. What that means is that instead of telling the machine, here's the algorithm and here's the data I want you to train the algorithm on, rather, with Turi Create you say, alright, the task is recommender systems. This is the data. Now go choose a model that would work best with the data that I've provided. And Turi Create will automatically go through a bunch of different options and find the model that will work best for your needs. And if you need to, you can specify an algorithm that Turi Create already has support for. And then you can export these models to CoreML. And now with the new CoreML 2.0, you have support for example, model quantization. So if you've got huge models, you can actually scale down the number of bits that each and every weight is encoded with, and you can actually create custom models that are, for example, 8 times less the size, which would allow you to create smaller applications that take up less space on a user's device and take less time to download. And of course, it also supports custom models. And with custom models, you can implement things like recommender systems and even merge multiple models into one model with individual connecting custom layers. Really interesting what CoreML 2 has to offer, but that's a separate video altogether. Back to Turi Create. Now, the entire point of Turi Create is to be able to process huge data sets. By huge, I mean in the billions of data points and millions of features in each data point category. And the best part? You can do this mostly on a MacBook Pro. And if you have, again, billions of data points, you can do this on an iMac Pro. You do not need to go to the cloud, and you can do everything locally on the computers you probably already have, which is why this is so fascinating. Now, back to movie recommendation. You see, the Movie Lens dataset has 26 million rows. These rows consist of user ID, the ID of the movie that this user watched, and a rating on a scale of 1 to 5, with of course decimals allowed, so you can do, for example, a 3.5 star rating. And so essentially it's a bunch of ratings from different users, 26 million ratings to be exact, that they've gathered over the years, and almost every few months they continuously update this database. So you have more and more movies, movie IDs, you have more and more IMDb and TMDb IDs associated with those movies, so you can actually go ahead and link them over to an API, get covers, descriptions, cast, whatever you need to get. And from there you can train movie recommender systems. Now when you bring these two together, you're able to analyze 26 million rows worth of movie recommendation data almost instantly in under a minute on a MacBook Pro. And I'm talking the model before the late 2016 model. And so this is really interesting. Let's take a look at how exactly the application will work. Of course, to begin, we need to start off with the data set. As I mentioned, in this case, we're going to use the Movie Lens dataset. And the Movie Lens dataset, again, 26 million different rows. It's great for training. Now, Movie Lens is going to be fed into a library called Turi Create. Turi Create, of course, is the open source version of GraphLab Create, open sourced by Apple. Now, on the other end, we're going to have an iOS application, and we're going to have a user interacting with this iOS application. But there needs to be a way for this iOS application and this Turi Create application to be linked. So there are two steps that go in between them. So we have Flask, and Flask is essentially a small HTTP server written in Python. And of course, we've got a little bit of NGROK in the middle over here. Now what's happening over here is Turi Create is sending its data over to Flask, and Flask is sending whatever data it has to Turi Create. And now Flask and iOS need to be able to communicate, so iOS can call this REST API. And so in order to do that, I set up a little ngrok endpoint that's going to basically act as a little bridge in between iOS and Flask. It's really that simple in terms of communication. Now, wait, I thought I told you that we could download CoreML models or export CoreML models and actually implement them in iOS. And that's true, you can do that. You can actually implement these Turi Create models onto CoreML on iOS. But there's a little bit of a problem with that right now. First of all, that's only supported with the newer versions of the operating systems that Apple has. iOS 12, macOS Mojave, watchOS 5, and tvOS 12. And the second problem is that there are currently a few different bugs with how exactly you implement CoreML models onto the phone. Like, for example, working with different kinds of architectures like the simulator's x86 and an actual phone's ARM64 doesn't exactly work because of bitcode not being enabled in the frameworks. However, by this September, when the latest releases or the stable releases of the new iOS, macOS, and other operating systems are out, that's when you're actually going to see me translating this code pattern to work natively on iOS without having to need any of this back-end communication between iOS and Turi Create running on the IBM cloud. And so, that is how this code pattern works. So, again, we've got the user communicating with the iOS application, telling the iOS app exactly what they like, and the way the iOS app enables them to do that is by actually communicating with and using the Movie Lens database and showing them a kind of graphical user interface for Movie Lens. And so essentially we just import the Movie Lens database into a UI table view and then use the IMDb API in order to actually scrape off, for example, albums and real titles and descriptions, and then store those ratings locally. And when you ask it to recommend new movies for you, it's going to go ahead and call this whole REST API. And so that is how this code pattern works. And now, let's head over to the coding part, where I'm going to show you how exactly you can actually implement all of this. And of course, if you'd like to take a look at the code pattern itself, you can take a look at that down in the description below. Alright, so welcome back to the code part, and now I'm going to show you how you can actually go ahead and create this code pattern. Now, as you can see, this over here is the code pattern on GitHub itself. Now, if you like, you can actually go ahead, click the link in the description below. It's on the IBM GitHub page. You can go ahead and clone down the GitHub repo, and then once you've cloned it, you can go ahead and follow these steps or follow this YouTube tutorial and go ahead and actually run all the steps and actually create this application. So what I'm going to do is I'm actually going to show you how you can do that step by step. Once you clone the model locally into the Turi Create Movie Recommender folder, you're going to go ahead and start off in the local model training folder. This is where you're actually going to go ahead and train your model. But before you can train your model, you need data. So go back to its root directory, which is the actual Git repo, and run the setup.sh script. What this is going to do is it's going to go ahead and download the Movie Lens latest zip file. Now, this is the latest file, so it'll always keep changing every time the Movie Lens database has an update, say some more users or some more items. This will update, so it's not actually calling a specific version of Movie Lens. In fact, that kind of feature is not available readily from Movie Lens unless you were to host it yourself. And so, right as the Movie Lens database is done downloading, it's going to go ahead, unzip, and it's going to take a bunch of the different CSV files that Movie Lens provides, and whichever ones are useful, it'll move to their respective directories. Like, for example, there are some sort of index documents that are useful for the iOS application so that users can actually search up for their favorite movies, rate them, and then get recommendations. But there are some that are going to be useful for training, like, for example, which users are associated to which movies and with which rating. And so that's what's going to be moved into its respective directory. So now I'm just going to speed up the clip until it's done downloading this file. All right, so as you can see, it's done downloading the file. It's now unzipping, and then it'll just move the correct CSVs to the correct places. And as you can see, it's done setting up. Now we can head back over to the local model training. And again, this is written in Python 2.7, so this is not compatible with Python 3 just yet. But if you'd like to make it compatible, please feel free to contribute to the GitHub repo. Go ahead and run your Jupyter Notebook. Of course, this code pattern will assume that you already have a Jupyter Notebook set up. And I'm going to go ahead and actually quit Safari so I can go ahead and open this up in Google Chrome. So I'm going to take this token link that's provided to me here, and I'm going to go here into the notebook. And just like that, you can see the notebook. As you can see, the notebook is actually going to guide you through step by step what's happening at each line of code. In fact, Turi Create is exceptionally simple to use. All you do is you import it, you read a CSV into an S frame, you delete the columns that aren't relevant to your data, you can print it out just to debug, and then you create your model. In this case, I'm creating an item similarity recommender, and I provide it the user ratings, and I tell it the user ID is the user ID column, the item ID is the movie ID column, and the target that we're trying to predict, or the target that we're basing this off of, is the rating. Then I just save the model as movie rec. Now, I would like to note that Turi Create models are special. They're not saved as files, they're saved as folders. And so what this means is that, well, you have a folder called movie rec, which has a bunch of different files that Turi Create will use. Then I can go ahead and run all these cells. As you can see, it's going to import Turi Create. I'm currently running the second beta of version 5. It's going to read the CSV practically instantly, and we've got a very impressive number of lines here. We've got 26,024,289 lines read in 7.28 seconds on a MacBook Pro, which is very impressive. I then delete the timestamp, print out the ratings, and then create the model. As you can see, it's going through. In total, we have 270,896 users and 45,115 items, and it prepared the data in less than 17 seconds. Now it's going to go ahead and actually create or train the model. As you can see, it was able to actually get some statistics, like some bare bones statistics, in less than a second. In fact, just over half a second. And now it's going to go ahead and actually go through the whole data set, and I can guarantee that within 60 seconds, it'll be done going through the whole data set. I'm going to speed this up for you since I don't want to have you watch paint dry. All right, as you can see, I was off by just 30 seconds here, but again, in a very, very short amount of time, in fact, 92 seconds, I was able to get a recommender system off of 26 million rows, 240,000 users, 45,000 items rated. I was able to go ahead and get a very accurate, actually, as you'll see in just a moment, movie recommendation system, and I was able to export it over here. If you'd like to export it to CoreML, you can find out how to do so on the GitHub Turi Create page. Now let's head back over to the terminal, and let's head over to the next important folder. This is the server-side prediction API folder. This is where you're going to host your Flask server. But in order to do it, you need to get a model in here. So you just move You just find where exactly the local model training folder is, and you move the movie rec folder, which is actually the model, to this current directory. Once it's in here, then you just run your Flask app. The way you're going to do that is by setting the Flask app environment variable to backend.py, and then just do a quick Flask run. There we go. Flask is indeed running. And now, in order for your iOS application to access Flask, go ahead and run an ngrok instance. Now, in this case, I've registered a reserved subdomain with ngrok called movie recommend. There we go. Now, if you go to movierecommend.ngrok.io, it's going to point to my localhost 5000. Then I can head over to my iOS front end, and this is where the magic happens. I'm going to go ahead into the movie recommender folder, and this is the actual sort of Xcode project folder. First thing I'm going to do is run pod install to install my Cocoa pods, which will be all my dependencies like a LamoFire and a LamoFire Swifty.json for actually doing communications with networking, csv.swift to actually index my data, and of course Swifty.json to deal with JSON. And there we go. Now I can go ahead and open up my movierecommender.xc workspace. Oh, misspelled open there. And then all I need to do is wait a second, and it should open up Xcode for me. Now, I would like you to note that I am indeed running macOS Mojave and Xcode 10 along with iOS 12. However, this is meant to work with iOS 11 and is really only backwards compatible here. This is not meant really to work with iOS 12. If it were, then I would actually be using the export to CoreML feature. However, that's going to be in a separate branch very soon on the Git repository. And very soon in September, once Apple releases their Golden Master version, it will be merged into Master. All right. As you can see, it's going to go ahead and launch this movie recommender application onto an iPhone X simulator. Now, as this is launching, I'd like you to note one thing. As you can see, inside of Xcode, that setup script has actually moved the CSVs into the correct location. But at the same time, you have to realize that we're dealing with approximately 45,844 different movies here, and we're dealing with that across 2 different files. Now, all these data points need to be joined, and they need to be processed. And so what that means is that it might take a little bit of time to get started because, well, you need to index all of this data and make it so the iOS application can actually use it. So the first run that you make of this application will take around 5 minutes to actually index all the data. Of course, it'll take probably less than 5 minutes. I'm just saying that in sort of the worst case, it'll take around 5 minutes. However, every other run after that should take approximately 2 seconds maximum to load up, because after that, the data would have been indexed. Now let's head back over to the iOS application, and as you can see, I've already fed in a few of my favorite movies: the Home Alone 3, Home Alone 4, Matilda, Despicable Me, and Despicable Me 2. Now, if I wanted to, I could actually go ahead and add some more movies in, and I'd search for the movies over here. So all I do is I type in the movie's name, say Brave, I search it up, and it'll use a Levenstein string distance algorithm and actually go ahead and search all of those rows in a multi-threaded fashion almost instantly. Really just takes maximum 3 seconds. I can go ahead and rate the movie, for example, 5 stars. I then clear, and it brings me back to my current favorites, and it shows me the actual ratings for each of these movies. Now, all I need to do is click on What Should I Watch, and if everything worked just right, it should tell me what I should watch next. There we go. Now, these are my recommendations over here, but the funny part is that I've already watched a few of these movies, and I just had not actually put them in the favorites list. Like, for example, Frozen. I'd rate that a good 5 stars. Wreck-It Ralph, I'd rate that a good 5 stars. I haven't watched Tangled yet, but I'll definitely do that soon. Monsters University, I'd give that a 4. How to Train Your Dragon, haven't really watched that. Megamind, 5, and there we go. Now I can clear. As you can see, it's added these movies to my favorites. And by complete coincidence, I'd actually watched these, and the neural network was able to recommend these movies because it thought I'd like them, which is really amazing if you think about it. It was able to read my mind, quite literally. And then I just click on What Should I Watch, and it gives me even more personalized recommendations. And then I can just go ahead and continuously rate. And after a few rounds of rating, the model will have a good idea as to what kinds of movies you like, what kinds of movies you don't like, and then you can just expand it from there and make it even bigger. The entire architecture of the application is actually relatively simple. If you open up the main.storyboard, you can see we've got a few main views. In fact, we've only really got two or one main view. Well, I mean, we've got the navigation controller to the left here, and then we've got just one view over here that does all of the work. It's called a favorite search view controller, and it'll actually show you your favorites by default, but it'll also help you search for different movies, and at the same time, it's going to help you actually get recommendations and show them out on this view. Of course, there are a few prototype cells that I've put into this table view. In fact, I've only really put one. It will show the sort of cover or the poster of the movie over here to the left here. It'll show the title, and it'll show the year that the movie was released. And of course, it can actually either A, provide you the functionality for you to actually give a rating, or it'll actually provide the functionality to change this label into the rating that you've already given if you're on the My Favorites page. And then you've got a few .swift files that actually go ahead and sort of orchestrate all of the work. Like, for example, in the favorite search view controller, you've got code that will actually go ahead, decide what's actually happening right now. For example, are you searching? Are you taking a look at your favorites? Or are you getting recommendations? And depending on what's happening, it's going to change the content in the table view, depending on, for example, should you actually have the option to rate? Should you see the ratings that you've already provided, etc. In fact, this is all done also via the movie table view cell. In fact, this is actually where I make API calls to the TMDB API. The TMDB API is the movie database API. And then, of course, in the movie handler over here, I basically have this class to deal with the API that does the movie recommendation. Of course, in September, this class will be gone because you won't need this anymore, or at least some sections of this class will be gone because everything will be done locally. There are a few, however, that will stay. Like, for example, this function over here actually uses a multi-threaded approach along with the Levenstein string edit distance algorithm in order to search all those movies to find the movies that you're looking for. And then, of course, the recommend function over here. Also got a few quick extensions to some classes, like, for example, in array, you can actually chunk arrays into numerous different arrays now with this extension. There's also a synchronized array. There will be a link to the synchronized array down in the description below by a great blogger online. He's done some great work with the synchronized array. Really, it's amazing. It allows you to have arrays that are synchronized across multiple threads. And of course, some quick string extensions. One for the Levenstein distance, and one of them is just to encode strings as certain in a certain encoding. Of course, we've also got the two CSV files, and of course the app.delegate.swift. That's really not doing much work here, at least customized work. And that is a quick overview of the code and how exactly you can build a movie recommender system with this code pattern. I really do hope you enjoyed this tutorial. Again, if you'd like to build this system for yourself, I definitely recommend you head over to this GitHub repository. It's on the IBM GitHub page. There'll be a link to it down in the description below. And that's what I had for this tutorial today. Again, I really do hope you enjoyed. And if you did, please do make sure to leave a like down below. Share it with anyone you believe could benefit from it, like your friends or family. Apart from that, if you really do like this content and you do want to see more of it, please do consider subscribing to the channel, as it really does help out a lot. And of course, turning on notifications by clicking the bell icon if you'd like to be notified whenever I release a new video. If you do have any comments, suggestions, feedback, I'd love to hear it down in the comments section below, or you can email me at tagimani@gmail.com or tweet to me at tagimani. Apart from that, that's all for this tutorial. Again, really do hope you enjoyed. Thank you very much. Goodbye for now.